instructed that observe the diagram of a simple pendulum below and then answer the next questions. So the setup is this one. Now let's see the questions. State at which 2 points does the bulb possess maximum potential energy. Now, to start well, this interconversion of the energy where kinetic energy and potential energy interchange each other, first of all, you have to know clear about this diagram. This diagram is a simple pendulum whereby we see there is a pendulum bulb. This pendulum bulb oscillates from one point to another, as you see, to and fro. It means that a pendulum bulb at point D is at equilibrium position. So it can swing towards A, and from A it swings back up to point G. You have to know that as the bulb oscillates at point A and point G, it is where it attains maximum height. So at these 2 points, its velocity becomes 0. So it attains maximum height and its velocity becomes 0. So from point A to point B, the velocity starts to increase from 0. Increases, and when it reaches at point D, it possesses maximum velocity. So at point D, the bulb attains maximum kinetic energy. This kinetic energy starts decreasing as it ascends via point E, point F, and again at point G, the bulb attains maximum height and its velocity becomes 0 as it has started decreasing from point D up to G. The same, the bulb after reaching at point G, whereby it attains again maximum height, it starts to go back, it starts to oscillate back towards point A. Now, its velocity again starts to increase from 0, increases as it passes through point F, E, and again at point D, a bulb attains maximum velocity, and here again it attains maximum kinetic energy, whereby the potential energy at point D is equal to 0 as its height is 0. As it reaches at point D, it starts again to ascend up to point A. Now its velocity starts decreasing. So, and when again it reaches at point A, its velocity becomes 0, while its height becomes maximum. So at point A and G, you can recognize that a bulb possesses maximum potential energy, which is equal to the mechanical energy, and at point A and G, the kinetic energy becomes 0. Why? Because its velocity is equal to 0. So as kinetic energy is obtained by taking a half m times the velocity square, so it means that velocity is 0. So the energy will be 0 at point A and G as its velocity is 0. So regardless the body has mass, but as the velocity is 0, the kinetic energy will be 0 at point A and G. But at point A and G, the potential energy is maximum because it has maximum height. As potential energy is equal to mgh, I mean mass times gravitational force times height. Now it means that it has maximum height. So even potential energy will be maximum. Potential energy will be maximum at point A and G. As I told you that at point D, a bulb has maximum velocity. So the kinetic energy at this point is maximum. So it has maximum kinetic energy, where the potential energy is 0 as the height of the bulb at point D is 0. Now let's answer these questions. The answer for the first question, to state 2 points whereby a bulb possesses maximum potential energy, as I have told you, that is at point A and G. Now the answer here is at point A and G, where the bulb possesses maximum potential energy. As I told you that, why? Because at A and G, a bulb possesses maximum height. Fourth question. To state a point where a bulb attains maximum kinetic energy. A point means that a single point. As I've told before, that a single point where a bulb attains maximum kinetic energy, it is at the point where it attains maximum velocity is at point D. So at point D is where a bulb attains maximum velocity. So the same as kinetic energy is equal to a half mass times velocity square. So it means that at the maximum velocity is where the kinetic energy will be maximum, is at point D. After this lesson, I hope you have understood well how interconversion of kinetic energy and potential energy takes place through an oscillating pendulum bulb, as you have seen. So, thank you for attending today's session. I take this chance to welcome you in the next sessions. Have a nice moment. Bye.